Hi everyone. In this video we're going to talk about enzyme inhibitors. An enzyme inhibitor is a substance that either slows or can possibly stop an enzymatically catalyzed reaction. There's three main types of enzyme inhibitors. We'll go through these one at a time. The first is called a reversible competitive inhibitor. Let's just define a couple important things about a substance that might be a reversible competitive inhibitor. As implied, it binds reversibly to the enzyme, okay? So binds reversibly. Another key component to a reversible competitive inhibitor is that its structure often mimics the normal substrate. And I'll put mimics in quotations. So this inhibitor compound is often going to have a very similar structure. It may not be exactly the same, or actually it can't be exactly the same, but it's going to have a structure that's going to closely mimic the normal substrate, but can't be converted then to product. All right, so I'm going to use these sort of cloud diagrams that I'll draw my enzymes as sort of the cloud diagram to help illustrate this. So recall we can sort of draw an enzyme with its active site looking something like that. So here we have our enzyme. And let's say that our normal substrate looks like this. All right, so this now can bind. We could go through our normal process of forming the E.S complex. This is going to be converted into the enzyme product complex. Let's say my product now looks like a circle. And then if this were to undergo normal reactivity now, the enzyme is now going to release my product. Oops. Make that back into a triangular mouth. So there's my enzyme. It's going to cycle back. And I also am going to release product. So let's say that's the normal state of affairs. However, if I were to add a compound that may mimic the structure of the substrate, we're going to call that an inhibitor, I. Okay, let's say that inhibitor now, let's say it has even more interactions in the active site that allow it to bind tighter than the substrate. This is now going to allow us to form an enzyme inhibitor complex, E.I. And if this binding is really, really tight, or the affinity for the inhibitor for the enzyme is tighter than the substrate, it essentially is going to divert the enzyme over into this sort of dead end over here. Okay, notice that the inhibitor now can't be converted to product. Okay, and it's preventing substrate from getting into the enzyme's active site. That's why this is called a competitive inhibitor. Okay, it's actually competing with the substrate for the active site of the enzyme. Okay, so that's the first type of inhibitor. You're going to learn a lot more about this if you ever were to take pharmacology, but probably close to 50 to 60% of all the various pharmaceuticals that we use, maybe even more than that, are these types of inhibitors. They're going to reversibly bind to the enzyme and outcompete the normal substrate. Another key component here I'll just mention is that the inhibitor is held into the enzyme's active site by reversible interaction. So this could go backwards, but if this is a very tight affinitive complex, it essentially diverts enzyme into this sort of catalytic dead end, if you will. All right, so in the next section, we're going to look at number 2, which is going to be called reversible non-competitive inhibitors. All right, so the second main type of enzyme inhibitor is classified as a reversible non-competitive inhibitor. And these are very different. These are substances that bind to sites other than the active site. And they often, in almost all cases, do not mimic the substrate in any way. So to think about this, let's draw our enzyme cloud diagram. I'm going to draw it a little bit different way now. Okay, so here's my enzyme. Now notice I've put this sort of indentation over on the site that's not going to be my active site. So again, if we have our normal substrate, okay, that could now bind to our enzyme. So we get our enzyme substrate complex. That can be converted now into our enzyme product complex. I'll just write it like this. And then finally, our enzyme is now re-released. And we would now get our product out. Okay, an enzyme obviously could then recycle back and catalyze another reaction. Now the key with this type of inhibition is that our inhibitor is not going to be binding to our sort of triangular shaped active site. In this case, I have a very different shaped molecule. I'll call it I, and I'll make it a circle over here. It's going to bind to some site other than the active site, and in doing so, it's going to cause a shift or a change in the three-dimensional structure, thus changing the shape of the active site. So let's say now that my inhibitor now binds, and I'll put that down here. But now, let's say my active site now dramatically changes its shape. Okay, I've now made it look kind of like a square. Substrate now might still be able to bind, but it's not going to be very good. But let's say that it could actually bind. Let's say substrate now is here. If substrate now binds, I could potentially now get a complex that's going to look like this. Where my substrate is sort of bound in a not very good active site. Okay, so it's not really matched up very well. This is called an E.I.S complex. It's got actually both the substrate and inhibitor bound. But when this is bound, it's not going to be able to do the catalysis very well. Okay, so if substrate now, again, binds to this E.I complex, we could get to this state. Now the difference between the non-competitive and the competitive inhibitor that we talked about before is that this isn't necessarily a dead end. Notice what could happen. I can sort of complete this cycle if the inhibitor simply falls off. So I remove the inhibitor. Now my active site could go back to the way it's supposed to look and now do the catalysis, converting substrate into product. Okay? So the behavior of these types of inhibitors is very, very different than the non-competitive. Probably close to 30% of all pharmaceuticals exhibit this type of inhibition. And again, the keys are that these bind to a site other than the active site, and they basically do not typically mimic the structure of the substrate in any way. All right, the last type of inhibitor we're going to talk about, the irreversible inhibitor. These are compounds that could covalently bind or attach to an enzyme, often either directly in the active site or maybe blocking the active site, and essentially killing its activity. It essentially irreversibly converts the enzyme into something that's not really useful. So let's look at an example here. So here's my enzyme, here's my active site. Let's say I have a serine hydroxyl that's really important for catalysis, or it's sitting right there in the active site. If I have some drug molecule that now has some sort of leaving group on it or some sort of activated group, this compound sometimes can mimic the substrate to kind of trick the enzyme into binding it, but doesn't necessarily have to. It could just be close enough in structure so that it's going to now possibly be bound close to this OH group. And if I now go through a reaction, this is essentially going to be an irreversible reaction. So now my enzyme is now covalently linked. Okay, so I've now formed a new covalent bond right there, and my leaving group or activating group is now displaced. This now, notice, cannot go backwards. The enzyme is now stuck, and this part right here, the inhibitor, is now blocking the active site so that normal substrate can now no longer come in and bind in this way. And there are numerous examples of various drugs that do this sort of irreversible reaction. These types of substances, these irreversible inhibitors, are often toxic. So various toxins often work in this way. One in particular is actually the penicillins. Penicillins are toxic to bacteria. Fortunately, they're not toxic to humans or other mammals, so we can use them to kill bacteria, but they don't kill our cells. And the way they do that is they actually react with an active site serine, and they basically block the active site of the bacterial enzymes that are needed for bacteria to grow. All right, so that covers the three main types of enzyme inhibitors. We had two of them that were reversible. We had the competitive, which mimic the normal substrate, and then we had the reversible non-competitive, which bind to some other site than the active site. And then finally, these irreversible inhibitors, which covalently attach to and essentially kill an enzyme. All right, so that wraps up our discussion of enzyme inhibitors. Make sure you do a few more problems to look at the differences between the three. Good luck.